Hey everybody, Greg here. How are you? It's Sunday evening, November 15th. Very cold, rainy day in Oregon. And the room has a little bit of a hue to it because I'm starting to use my full spectrum lamp here. A lot of people up here use these in the winter. It gives the same frequency as natural sunlight and just makes you feel quite a bit better. But I never usually have too hard of a time. It's January and February when it starts to get pretty tough when you haven't seen the sun in 8 days. But we're doing all right. Anyway, so it was a good week, and I just have a couple of things I want to talk about on correlation. Now, I think everybody did a pretty good job. One of the things that I noticed is don't confuse correlation with comparing. If You'll see this in the media a lot. If you wanted to know if the mean amount of, I don't know, if you wanted to know what the cholesterol level was in male, the mean level of LDL in males, and you wanted to compare that to the mean level of LDL in females, that's not correlation, that's comparing. You're comparing two groups because male female is a categorical variable. It's either or, it's not continuous. Now, the LDL level is continuous, but that's not a correlation that you're doing. You're comparing two groups to see if the means are different. That would be done with a two sample t-test, which we will do not this week, but next week. So we're all pretty solid on correlation. And the other thing is, with correlation, the thing that you have to keep in mind is it's in quantitative research, it's that there's no room for interpretation at a certain level. Now, so you saw that correlation study, they did a lot of speculating on relationships. But ultimately, it comes down to one thing. There's a null hypothesis in which says that in the general population, there is zero correlation. And then there is the alternative hypothesis, which says there is a non-zero correlation. And remember, you can never accept the alternative hypothesis. You can only find evidence for it if your p-value is too low. So correlation is pretty simple. All correlation studies do a lot of speculating, but when it gets down to the methods section, it's pretty exact. It's null hypothesis, alternative hypothesis. It shows the data pairs, the R, the p-value, and then says whether it's a statistically significant correlation or not. And that's why I like that study. It's right to the point. So anyway, you've started hypothesis testing. Now we take it to another level this week. So let me give you an example. Let's say I have a null hypothesis, and I say that the mean length of the cat's tails in my county is 8 inches. So my HO is that the mean is 8. So that's what is commonly believed, or that's what science believes, but that's the null hypothesis. Well, then my research hypothesis, or my alternative hypothesis, would be that the mean length of the cat's tails is not 8 inches. So that's my HA there, as you can see. So we're going to do this week what are called one sample t-tests. And the idea there is to take a sample and see if we can reject a null hypothesis or not. So here's my example. When you do a one sample t-test, you will use another calculator, another quick calcs, and this one is pretty good too. So let's say I believe that the mean length of the cat's tails in the county is 8 inches. And my research hypothesis then is that it's not. All right, so I go and I start the calculator and I put in a hypothetical mean value of 8, and then I put in my 6 samples. So I randomly sample 6 cats, measure their tails, let them go, and there's my sample. Now, when I put that sample in, I'm going to get some things. I'm going to get what's called a t-value, which in this case is 2.7. I'm going to get my degrees of freedom, which in this case is the sample size minus 1 for 5. And then I'm going to get my p-value, which in this case is 0.0409. So what does that mean? Since the p-value is lower than the standard alpha of 0.05, I can reject the null hypothesis that the mean length of the cat's tails in the county is 8 inches in favor of the alternative, which it is not. And so as we're starting to learn, don't forget, you never accept the alternative. You only find strong evidence for it. In fact, what the p-value means is that by rejecting the null hypothesis, you only have a 4% chance that you're wrong, but you still could be wrong. You can always be wrong about a population parameter from a sample unless the sample was the same size as the population, and that will never happen. So I think people are starting to get onto that. So we will use the null and alternative hypothesis again this week. And then this week you will also formulate your one sample hypothesis test result in APA format. And that is on the sheet that I sent out, and we will make sure that we do that during the week too. So those three things, when you conduct the one sample t-test, the t-value, which is the test statistic, the degrees of freedom, and the p-value are important to know. The other thing that I think there was a little confusion on is the p-value is the result of the sample in the statistical test. The alpha is the minimum probability of committing a type 1 error, and that is established before you do the statistical test. And in research, that's usually an alpha of 0.05. What that means is that the teacher establishes that 70% is passing. And what you get on the test is what you get. That would be your p-value. So the alpha is set ahead of time, and we can have a discussion on why the alpha is 0.05 at a later date. But that's what it always is, unless in the research it says it's something else. So what you're going to be doing in the first part of the week is you're going to be looking at 3 research papers. And these research papers are based on getting information from a population. Now, in a survey, you're going to be doing some survey research this week. There's a difference between a census survey and a sample survey. And you have to read the 3 research papers carefully. If I do a study on a private school and there's 25 students in it, and I study the mean, median, mode, everything, that's a census. That's not a sample. That's everything. And so and if I gave a survey to everybody in the school, that would be a census survey. A sample survey is what you get when you give to a sample of a population, all right? So in the United States, we try and take a census. We try and count everybody. Well, it rarely works, but that's what we try and do. A lot of statisticians have theorized that why don't we just take a sample of the United States and try and stratify the sample, and let's get the correct proportion of genders, income groups, racial groups, and actually that has a lot of merit to it. I don't think politically we're there where a lot of people would want to use a sample to create congressional districts, but it probably would have benefits. So there's a difference between a census survey and a sample survey. So you're going to look at 3 papers that do surveys in the first part of the week. Now the second part of the week, you're going to create your own instrument to gather information, and you're going to start out with a null hypothesis. So let's say I formulate a null hypothesis, and I say that on a scale of 1 to 5, in the population at large, the mean value on the barbecue awareness scale is 4.5. That's what most people believe. That's my null hypothesis. Just like most people believe that the mean value of the IQ in the population is 100. Well, then you're going to create a survey instrument that's going to ask questions, and you're going to try and determine a value for barbecue awareness or whatever construct you choose. And when you get those surveys back, those are going to be your samples. And from your samples, you're going to see if you can reject the null hypothesis that barbecue awareness in the population is 4.5 on that scale. Just like if I wanted to, if I disputed that the mean IQ in the population was 100, I would give an IQ test, which is essentially an instrument, to 50 random people, and I would see if I could reject the null hypothesis that the mean IQ is 100. So you're going to do a little survey research, but the key is to learn how to do the one sample t-test. It's not to make your survey very valid and reliable. That's for another course. So we're going to kind of have some fun. We're going to create some fictitious surveys, but you will learn the statistics behind them. So I think things are going pretty well. Now this hypothesis testing, it's now you. It's part of statistics. It always will be. And so these concepts of rejecting the null hypothesis, the probability of it committing a type 1 error, they continue now indefinitely. And I think we did a pretty good job on it. So I'm looking forward to another good week. One thing I do want to bring up, it's important to go and review the late work policy that's in the syllabus. We want to make sure we're getting all of the assignments in no later than Saturday night, so then we can grade them all and get them all back to everybody in a timely manner. And so there's some complications this week. If you need any help at all, please let me know. And everybody have just a great week. Okay, bye.